Namaste. Welcome to Tapovan, where learning meets stillness, where we learn deeply with code. In this third video in JavaScript series, we venture into the illusions of JavaScript, where number becomes strings, where Boolean pretends to be number, and where the very idea of truth can shift depending upon how you ask. This is the world of type coercions and Truthy Falsy, two of the most misunderstood, misquoted, and misused behaviors in all of JavaScript. Have you ever been stuck in questions like 5 plus 1, null equals to 0, true plus false, foo plus plus bar? Well, these aren't just gotchas. They follow a hidden logic. And in this video, we uncover exactly how that logic works. By end of this video, you will be in a position to solve most of the type coercions problem, not by memorizing the answer, but by seeing through the illusions. So stay with me and let's reveal how JavaScript really thinks. Let's start by visiting the data types in JavaScript. There are 8 basic data types in JavaScript: number, bigint, string, Boolean, null, undefined, symbol, and object. I'm not going to deep dive into these data types as of now. We'll touch base on these in the coming classes. The fact that I want to mention it right now is to discuss a point that JavaScript is a dynamically typed language. What that means is we can do something like value equals to 1, 2, 3, 4, and in the very next line we can assign it to a string. The fact that you can create a variable, assign it to a number, then the next line you can make it a string, and then something else altogether in the coming line. JavaScript does not complain. It simply nods and accepts. The variables are not locked to a type. They infer the type based on the value assigned. Now, the problem happens when sometimes JavaScript changes the type behind our back. And that is called as type coercion, and that is where the illusions begin. Let's now discuss about type conversions or coercions in detail. There are 2 types of type coercions, implicit and explicit. You would have seen something like 2 plus 2, which makes it 4. But if you do 2 plus string value of 2, now this converts the number 2 into a string and both the string concatenates, resulting in 22. If you do something like 6 divided by 3, now these both are string, right? But if we divide them, we get a number. Correct? So operators and functions, which we'll see, some of these functions, they automatically converts the value into the required type. In this case, the number gets converted to a string, and in this case, the string gets converted to a number. Now this is implicit conversion or coercion. How it is happening, we'll learn the logic and the rules shortly. If I do something like 1, 2, 3 plus Tapovan, this converts my number into a string and I get a complete string altogether, 1, 2, 3 Tapovan. Correct? If, however, I do something like this, my dear friend, number, and let's say I say 1, 2, 3. Now here I'm explicitly converting, trying to parse this number to a string. And this, my dear friend, is called as explicit coercion. Right? Since this had a valid number inside the string, it was able to convert it into a valid number. If we try to convert an alphanumeric string, JavaScript will say, hey, I don't know what this is. This is not a number. And that is what it says, NaN or not a number. If I try to do something like try to convert true, parse a true to a number, I get the value as 1. If I try to parse null into a number, I'll get 0. If I try to pass undefined, this again will be not a number. Correct? So we have seen string coercions, we have seen number coercions. Let's not talk about Boolean conversions or coercions. Now for Boolean coercions, they happen in logical context, like inside my if block or while blocks, right? Or if you're using logical operators like not, or. So it converts the entire content into a Boolean value, right? And JavaScript has a very clear rule. Some values, some values are always falsy. And what are those values? Well, there are six such values, like the false keyword itself, the zero, the empty string, the null keyword, the undefined, and nan. Now, if any of these six values are converted to a Boolean or coerced or coercion happens in a Boolean context, these six values will result in false. Everything else will be true, right? Let's see that. So if I do something of like Boolean of 100, now this is a non-zero number, so the value will be true. If I check Boolean of 0, it will be false. If I check Boolean of a string hello, this again will be true. What will happen if I do something like Boolean of 0? Now this is a non-empty string. Although the value is 0, but this is a non-empty string. Hence, if we try to convert this into a Boolean value, it will be true. Right? Boolean of empty string will be false. But if we even give a space, this becomes a non-empty string and the resultant value will be true. Well, now that you know a little bit about type coercions, it is a good time to bring that interview question, very important and commonly asked interview question, the difference between double equals and triple equals operator. And most common answer that you will hear is that double equals just check for the values, while triple equals or the strict equality operator check for both type and values. While that might lead to correct answer, that is not the complete answer. That is just a part of the truth. The complete answer, my dear friend, is pay attention. This is a very important distinction that the triple equals or the strict equality operator does not trigger coercion. It just checks for what is left, what is right, compares and checks for both type and values. While your double equals or the loose equality operator, this, my dear friend, does the comparison, but before that, if there is a possibility, it will also do type coercion if needed. Right? Before it compare, it asks, can I convert both the types to match and look alike? If the types are different to the left and right, it tries to coerce, it tries to do the implicit conversion of one of the type, of one of the values. So the comparison with double equals to, my dear friend, happens in two steps. First, type coercion if needed. If the types are different, it does type coercion and then it does the comparison. Which is why when we write something like 2 triple equals to 2, this is false. Your strict equality operator checks left and right, the types and values. The types itself does not match, it says false. But if we do 2 equals double equals to 2, now here it tries to convert this string to a number. So this becomes 2 double equals to 2 and then the answer is true. Okay, so the next logical question in your mind should be, what are the rules of this conversion? How do I understand in what situation a number becomes a string or when does a string becomes a number? To do that, let us learn to play a game. And to play any game, we need to understand the rules of the game. That is how the game becomes interesting, right? Yeah. So let's learn the rules of the game now. These are the rules for the implicit conversion. The first rule is that there are only three types of conversion, either to string, to Boolean, or to a number. Second rule is, when is the string conversion triggered? What are the case when the string conversion happen? And the case, my dear friend, is when there is a binary plus operator and any of the operand is string. Like in this case, we have a plus operator and then one of the operand here we see is a string. It does not matter whether the left one is a string or the right. Either one of them should be a string and there should be a plus operator. And It will convert the other operand also to a string and concatenate. This is the second rule of the game. The third is the rules when the numeric conversions are triggered. Let us see that. Whenever we are using comparison operator, greater than, less than, greater than, equals to, less than, equal to, then a numeric conversion is triggered. Whenever we are using arithmetic operators like plus, minus, division, multiplication. Now, if you see, the plus operator is here as well. But if this situation arises, then the second rule takes precedence. If there is a plus operator and then one of the operand is a string, then the second rule will take precedence. Okay. Otherwise, it will be a arithmetic operator plus, and it will result in numeric conversion. Whenever you're using unary plus operator, then also numeric conversion will be triggered. Whenever we are using loose equality operator, which we just discussed, the double equals, the not equals to. Let us see some example. So if there is a unary operator before a valid number enclosed in a string, then this string will be converted to a number. A numeric conversion will happen. 1, 2, 3 not equals to 4, 5, 6, where both are inside string. 1, 2, 3 is also inside string, and 4, 5, 6 also inside string. Here also this will be converted to a number, and this also will be converted to a number, and then the comparison will be done. 4 greater than string value of 5. Here also there is a comparison operator. So the string gets coerced into a number, and then the comparison happens. Null divided by 5. What happens? This is the arithmetic operator, division. So the null gets converted to a number. So 0, null will be 0, right? We discussed. So 0 by 5 is 0. Right? So the first rule is that there are three types of conversion that happens. The second rule is to understand when the string conversion happens. The third rule is to understand when the numeric conversion happens. We'll see more examples so that it solidifies in your mind. And what fun is in the game if there are no special rules? The special rules in this game are that null equals only to null or undefined and does not equal to anything else. Nan does not equal to anything, even itself. For example, if we convert null double equals to 0, that will be false. No conversion will happen. The special rule applies when null is not equal to anything else other than null or undefined. On that note, null equals to null true, undefined equals to undefined is also true, null equals to undefined is also true. Now let us see some examples. All right, time for some quizzes to validate our learning. What will happen if I do something like this, my dear friend? Console log true plus false. What kind of conversions or coercions will take place? What will be the answer? Pause the video, think for a second, a minute, and then let's resume for the discussion. The answer for this will be 1. What is happening, my dear friend, is this is a plus arithmetic operator, right? So this rule does not apply because there's none of the operand is a string. The third rule applies where there is an arithmetic operator. It tries to convert true to a number and false to a number, right? So what happens in this case is true when getting converted to a number becomes 1. False when getting converted to a number becomes 0. So ultimately my equation reduces to 1 plus 0, which makes it 1. Right? Let's move to some different question. I'll omit the console logs. I'll just write the expression. So if I do something like this, 12 divided by 6, what will this result in? The value will be 2. Why is that? What kind of coercion will happen? Again, arithmetic operator is present, division, correct? So it will convert this string to a number. So this equation reduces to 12 by 6, which gives us the value 2. Let me write explanation so that it is easier for you to understand. Let's look at another question. Let's say I have something like a string number, then 1, then 2. What will be the answer of this? Again, pause the video, think for a second, then resume to see the discussion. Well, the answer will be number 1, 2. Why is that? The processing, the execution will happen left to right. So let's break this into smaller parts. Let's look at the highlighted section now. This is one of the operand is a string. There's a binary plus operator. So the second rule kicks in. So this becomes number 1, right? Number 1 and then plus 2. Then again this reduces. Again the same thing repeats where the left operand is a string and then we have a binary plus operator. So this 2 will be coerced to a string and concatenated, which makes the whole expression to number 1, 2. All right, let's see a tricky one. Let's say there's a foo plus, and then you have a unary operator with a string again. To give you a hint, unary operator will take precedence, so this part of your expression will be evaluated first. And what happens if we try to convert a alphanumeric string to a number? This part will become nan, not a number, right? So your expression reduces to foo plus not a number. And again, which of the rule will kick in, guys? Which of the rule will kick in, my dear friend, is that we have the left operand as a string and then a binary plus operator, and ultimately this thing will reduce to foonan. Let's say true equals to true. What will this case here? Again, this is a loose equality operator, and this will trigger a numeric conversion. This will result in false. Why will this result in false? Because true when getting converted to a number will become 1. And if we try to convert this true into a number, this will result in not a number. Ultimately, this entire thing will give me false. I hope you're getting the picture, right? So it's not just guesswork that we're doing here. We have understood the rules that are running behind the scene, and we're using those rules to deduce and get our answer. Let's move to the next one. Null equals to empty string. What kind of conversion will happen? Take a moment and guess the answer. I mean, tell the answer and then continue with the discussion. The answer will be false. Why? This is a trick one. Remember the special rules? Null equals only to null or undefined. So this result in false. No conversion or coercions will happen. Okay? So the explanation for this is special rule at play. All right, let's move on to the next question, and let's say 2 string minus 3. What happens here? What will be the answer? The answer will be minus 1. Why? Because we have an arithmetic operator. Subtraction. This becomes number 2. This becomes number 3, resulting in the value minus 1. What if I have 1 plus a string minus 2? What will this result in? Which of the rule will be triggered? One of the operand is string. Then we have a plus operator. So the rule number 2 will kick in, converting my left operand to a string. So this becomes 1 minus 2. Let's break down. This effectively translates into 1 being converted to a string, and then we have another string minus 2. Ultimately, two strings are combining 1 minus 2. Looks magical, but now you know the reason. What about 1 plus true? Again, a numeric conversion will happen, correct? And it will be, answer will be 2. Why? Because 1 is already a number, the true will be converted to a number, and ultimately the value will be 2. What about 1 plus null? The answer will be 1 again. because numeric conversion will take place. Effectively, your expression reduces to 1 plus 0, which makes the value as 1. Let's do one few very quick ones to understand so that there's no confusion whatsoever when you go back tomorrow, solve any of this type cohesion problem, you'll solve it with a lot more confidence. All right, let's look at this problem. 1 plus undefined. What will be the answer, my dear friend? The answer will be not a number. Why is that? Because again, the type conversion, the numeric conversion will take place as per the third rule. And undefined, when you're trying to convert this to a number, will become 1 plus not a number. Ultimately, you cannot do any mathematical operation with this, resulting in not a number. Let's say 1 plus null. What happens? In this case, think carefully and answer correctly. The answer, my dear friend, will be 1 null. Why? Again, you already have a string, one of the operand is string, you have a binary plus operator, so ultimately this becomes 1 plus your null being coerced into a string, and this becomes a complete string where the two smaller strings are joined together, concatenated. Right? Let's see a problem and then we'll conclude this. Let's say you have a variable a and which has the value abc. We are using unary operator, and in the next line we are doing console log a double equals to a. Note that triple equals to will not result, triple equals to does not trigger any type cohesion, right? We already closed that, we discussed that. It is only the double equals to where we have to discuss the different possibilities. Now our question is var a equals to plus abc. So here this string will be trying to convert into a number. What happens when you try to convert alphanumeric to a number? This becomes not a number. Ultimately, what we are doing is comparing not a number to itself, and this will result in false, right? We know that not a number is not equals to anything, not even itself, right? I hope with these rules, you'll be able to work in your interviews and such type cohesion problems and even in your day-to-day coding with a lot more confidence. Today we saw in JavaScript that truth can be falsy and falsity can be true. Numbers can become strings, string numbers, and even double equals to can lie. But the moment you learn the truth behind these illusions, it's no longer confusing. So the next time JavaScript feels to behave weird, pause and ask yourself, is it converting into a number? Is it coercing into a string or a boolean? That clarity is your power. This is the Tapovan way, not just writing code, but seeing through it. I'll see you in the next video.